So, we're loading. Of course we're loading. Okay, good afternoon everyone. My name is Phil Cluff. I work for Bright Cove, as Matt said. I'm British, I'm from England. I used to work at the BBC, which apparently explains the accent, I heard someone say down here. The title of this talk is What's in the Box, and it's going to be a bit of an explorative tour of MP4 and fragmented MP4. The reference here, and a few people have asked, is a movie called Seven. And it's actually a pretty bad movie. I don't recommend going and watching it. It's just a pretty good reference to what's in the box. So, like I said, I'm a British software engineer, ex-BBC iPlayer. I now work at Bright Cove. I get to play with video a lot, which is nice, and I have a really good time doing it. And I'm the inventor of something called MPEGSash, which is a free patent unencumbered version of MPEG-Dash, which you should all check out and talk about and get excited about. But I'll just mention that in passing. So, obviously. We are. So this session, this is going to be an example-driven session, which roughly translates as you get to watch me make typos in a terminal. So all the slides actually contain all commands I run, but I'm going to actually run them right in front of you. It's a dive into it. It cannot be a complete guide to fragmented MP4 or MP4. That's too much to fit into 30 minutes. But what it's going to do is expose you to a load of the tool that's ready available. There's loads of tools here that'll let you get started really easily. And hopefully it'll encourage you all to go off and do some digging yourselves, because it's actually pretty simple to get started. So Matt gave a bit of a history lesson this morning. I'm going to give another history lesson now. Starting with a QuickTime file format from 2001. So Apple came up with QuickTime and QuickTime files, and that's where we all started, which is Qt and MOV files. And that turned out to actually be a pretty good kind of box model, pretty solid foundations for how to start building media files. So that got moved then into the MPEG-4 Part 1 standard in 2001. The MPEG-4 Part 1 standard actually existed a few years before that in 1999, but didn't really contain much information on packaging up your MP4. So eventually this document's absolutely huge. It's well worth a nice historic read. But what happened is it got huge, and particular bits of it had particular patents encumbering them, other bits didn't. So what happened is container encoding and actually the systems as well all got split out into separate specs. So what we end up with is something called MPEG-4 Part 12 and MPEG-4 Part 14, where Part 12 defines a quite generic box format for storing media files in, and Part 14 actually specifies quite a specific set of requirements. And Part 14, in this case, and hang on, I'll get my pun in, every great presentation has a diagram. So this is my insurance. It's a diagram, heartlessly copy and pasted from Wikipedia. So like I said, MPEG-4 Part 12 is quite generic, a few rules in it, but kind of defines your box format. Then that's extended by Part 14, which gives you explicit rules. What we've got here is, interestingly, your progressive or download files are all Part 14, whereas your fragmented MP4 files are going to be Part 12. So I said it's called What's in the Box. So what is a box? And I've been using the word Atom pretty interchangeably. The words are pretty interchangeable. So these are the fundamental building blocks of what we build in MP4. They all have headers which define their type and their size. The reason they've got those headers, whoop, trashing in place. The reason they've got those headers is to allow these files to be really easily seekable on disk. And lots of atoms contain atoms underneath them. So every atom can define its own internal data structure, so you can't parse one atom with a rule for parsing another atom. Every atom can have its own internal data structure. So every atom is named with 4-character field using a mnemonic value, such as move. I try and pronounce these phonetically, so like move and futyup and push. So I'm actually trolling you, I don't. But yeah, I like to play the game of trying to pronounce these atoms. So, as the Beatles said, all you need is love. In this case, if you want to get started digging into MP4, all you need is Bento 4. It's one of the best ways to get started. It contains a bunch of tools: MP4 Dump, MP4 Edit, Encrypt, Decrypt, MP4 Fragment. There's loads of stuff in there which will allow you to get started. Get it from bento4.com. There's no SSL download, unfortunately. One of those is, I'm assured, coming. MP4 box is another option. It's also pretty comprehensive. It's an alternative. It has its own issues, but then so does Bento. And all these kind of under relatively open licenses. Again, in this session, I'm going to use media info quite a bit. hopefully a lot of you are pretty used to media info, and you can use hex edit if you want to edit your MP4 files as well. You'll probably have less success. So without further ado, I'm going to turn into a terminal. And unfortunately, I've got this on a 3-inch monitor to the left of me right now. So it's going to go pretty badly, so I'm actually going to turn on display mirroring because I might actually stand a chance, hopefully, of typing in a terminal. Okay, does that look good for everyone? So everyone can see that? Hey, everyone can see it. Cool, so what we're going to start with is we're going to... More zoom for the cameras. Make it bigger, there you go. So what we're going to do is we're going to start by getting ourselves an MP4 file. And actually, we're going to CD into my what's in the box directory first before I make a mess. And we're actually going to get rid of absolutely everything before we do it. Z-Shell's going to be really helpful and tell me I shouldn't do that. So first thing we're going to do is go and get ourselves an MP4 file. So I actually have one of these stashed away. It's Video.js's Oceans example. The internet here is, wow. What? This is, hey, it did eventually get here. Okay, I was a bit worried there, we weren't going to get it. So, here's where my typing forbids me. So, probably a lot of you have seen this before. We've all seen this, we don't need to really watch all of this again. Suffice it to say, it's a pretty standard MP4 file. So, where are we going to start here? So the first tool we're going to look at is actually MP4 Dump. MP4 Dump. Oceans.mp4, and we're actually going to stick it in less because our screen resolution is quite high. So what we see here is can everyone see kind of the far left characters? Pretty close. Let's shove it in a bit. Everyone see it now? Everyone can now see bits of my email, which is even better. So now what we see is kind of the fundamental building blocks of this MP4 file. So what we can see is an F-type atom, a move atom, which then has a bunch of embedded atoms in it, the MBHD, track atoms, and there's 2 track atoms, which we'll get into later. And then we have an MDAT atom at the end of it as well. So all we need kind of as a top level knowledge is, hey, there's 3 types of atom here, let's kind of think about what's going to be in each of those. Oh, well, thanks for that, Google. Quite why that decided to close my... oh, there it is. Okay, cool. So, our 3 top level box is F-type, which is file type, is what it's described as. So this describes the version of an MP4 spec we're complying to. It's a declarative box. The move atom, which is a movie header, describes the tracks contained within the MP4. And our MDAT, which is where our samples actually live, which is our movie data atom. So, we've only got 3 boxes. So, one of the other tools we've got here is MP4 Edit. So MP4 Edit will let us chop into files. So we'll look at its manual. So it can insert, remove, and replace atoms in an MP4 or FMP4 and the MP4 compliant container. Now, quite why you'd want to do this, there's many reasons, but you can do some quite cool stuff with this. So the first thing we're going to do is we're going to start chopping. Ooh. There's a lot of MP4 prefix tools on my machine, obviously. What we're going to do is we're going to remove an atom. And the atom we're going to remove is the F-type atom. So all we have to do is ask it to remove the F-type. And then we're going to give it oceans.mp4. And we're going to ask it to put it in oceans-nomove.mp4. Okay, it's done that. So we've chopped off that header. Do we think it's now going to play in, let's prefix this, in VLC, will this file now play? Who thinks yes? Okay, who thinks no? Well, actually, let's just assume there's an inverse there. Who doesn't know? So, unsurprisingly, yeah, it does actually play in VLC. Completely fine, funnily enough. It still scrubs, it still has audio, it still has video, all the things we kind of expect from happening here. So, okay, who thinks it'll play in QuickTime? Oh, this is where it gets fun. Oh, not many people think it'll open in QuickTime. Okay, you can go yes. Hey, guess what? It plays in QuickTime. Still plays in QuickTime. It's a bit of a surprise. QuickTime's pretty picky. There's no 2 ways about it. So, this file was called pleasework.mp4. That's great. If we now media info this file, what differences do you think we'll see having removed that header box? You want to take a guess? Well, it's pretty simple. It doesn't know some information. But if we now media info the new file, oceans-nm.mp4 and take a look at the top of it. Hey, guess what? Actually, it now thinks it's a QuickTime file. So if we actually look at this with a diff, so I actually have a diff over here. It used to be an ISO media file, an MP4 file. It's turned into an Apple QuickTime file. It's a bit weird. Hey, guess what? The F-type atom doesn't exist in the QuickTime spec, so everything's now, oh, okay, it's a QuickTime file. So, okay, that's pretty good fun. So now my next one, let's get moving. So, you get it? No? Okay. So, now we'll contemplate the move atom. So, this tells us information about the tracks in the file, among other bits and bobs. Our example, one audio, one video. So, if we go back to our MP4 dump, we're actually going to use an MP4 dump. We're just going to keep using this NM file now. So, if we do an MP4 dump on this, we should see that there's 2 track entries inside our move box. So our file now starts with a move box, there's no F-type. So under here we've got a first track here, and some declaration information. Notice it's done with the video handler. And then we've got a second track, which is actually our audio handler, so it's encoded with an audio handler. Okay, so what we're now going to do is go to MP4 edit again. And we're going to remove again. And we're going to remove the move/track atom. Now what this will do in this case is it'll remove the first track atom it encounters. What we can actually ask it to do is get rid of the second one, for example, or the first one if you want to do that. So you can also keep constructing here, so you could say, you know, add atom this / another atom block here. But what we're going to do is we're just going to get rid of the first track atom we encounter. And we're going to put it in oceans-nm- what should we call it, thu. Okay. So now what will happen if we play it? Will VLC play it? Everyone says yes. Open minus A, VLC, here we go. But something different, right? We don't actually have any video now. And just to kind of prove it, if I open VLC itself, yeah, there's actually no video in here at all. It's not like it hasn't played properly.
Can you make your terminal window a little
shorter? Shorter? In what respect?
People
Oh, okay. Oh, yeah, no problem. I can indeed. Well, less so than I thought, really. Well. Well, damn. There you go. Oh, no! This is amazing. Okay, right. Stop. There you go. You happy now? Okay. So yeah, so now we've chopped out those atoms, and now we've got data in there that we aren't using. That's kind of a bit of a lie. MP4 edit's actually smart enough to also go and remove the samples when you go and chop out a track declaration. So if you actually take a look at the file sizes, it has actually chopped out all of the video-related sample data in here and given us something that really just does only have one track in it. So, okay, we've done all of this. This will also keep playing in QuickTime at this stage, and it will just give us an audio file. So fragmented MP4, coming on to something more modern. It's a fundamental building block of Dash. You can use Dash with a bunch of other encoding types and delivery types as well. But it's also a building block of smooth streaming. And what it does is it defines a time-based MP4 file. So we retain our F-type and our move atoms, but what we start to gain is this move atom, and then our MDAT atoms change slightly. So our move atom becomes a header, which describes a following MDAT atom. So what you end up with is these pairs of MOOF and MDAT atoms inside your MP4 file. So hey, guess what? There's a tool, funnily enough, in Bento to do this. So we're going to use MP4 Fragment. There's a surprise. And what we're going to ask it to do is fragment-duration 4000. Why 4000, you ask? I hear all of you ask. There's a pretty good reason I'm fragmenting this file to 4000 milliseconds. It turns out to be a pretty good number. A lot of research has been done in this. 4 seconds is pretty good for doing this. I'm going to pass in our input file, and we're going to give ourselves an output file. Cool, we're done. So what we're going to do is we're going to do our MP4 dump again on this file. This time we're going to use our fragmented file, and we're going to stick it into less. Okay, so we've still got our F-type and our move, and some tracks. But guess what? Hey, then we start seeing these moofs and MDATs, moofs and MDATs, moofs and MDATs, moofs and MDATs, all the way down. Well, that's a bit of a lie, actually. At the end, we have a MFRA, but we're not going to talk about that. So we've got moofs and MDATs all the way down. So each of these contains roughly 4,000 milliseconds of audio and video in this case. So that's pretty cool. That file's still pretty useless to us. There's not really much we could do in terms of doing anything. You could actually chuck that into VLC and it'd still play. Probably chuck it into a lot of players these days and it'll still play quite happily. So there's two options as to where we go from here. What we can do is we can chop that file at every F-type, at every moof to the end of the MDAT, and what we'd end up with is something we could then serve on MPEG-live profile by using a segment template. But that's kind of boring and doesn't really introduce anything new. So instead what we're going to do is talk about SIDX, or SIDX. I always call it SIDX, but it's SIDX. So this is a sample index atom. You can actually have a load of them, but no one really seems to do that. They live as siblings to fragments. In this case, what we'll end up with is single SIDX following the move box. So these define locations of fragments in file, and they're used when you deliver MPEG-on-demand media. So how do we get ourselves a SIDX? Hey, guess what? There's another tool in Bento for this. So what we're going to do is, and I didn't get to prepare because, so there's a utils directory in Bento, which includes something called MP4-.py, and this tool is actually incredibly comprehensive. You can literally chuck a fragmented MP4 in this, ask it to do a particular profile of dash, and it'll kick that out for you. So in this case, what we're going to do is we're going to ask it to not split our file. So we want to keep, I think it's no hyphen split as well. So I don't want it to segment it into lots of little segments. And so I'm going to get this right, so bear with me on hyphen demand. And we're going to give it our FMP4. So we're asking it to split it, we're asking it to use the MPEG-on-demand profile, and we're telling it our input file. Off it goes, gives a bunch of output. Kind of ignore that. It's fine, honestly, it's fine. So now if we take a look at what we've got in our output directory, we've now got two MP4 files. So while we asked it not to split the file, it has actually split out the audio and video, which is actually what we want because it's really interesting. Source generator stream.mpd, so MPD is the extension you would use when you're delivering an MPEG-manifest. So if we do an MP4 dump again, actually let's go into the output directory first. And if we do another MP4 dump on, let's say, our audio for sake of argument, we see now F-type, move, and a single track, because this is just the audio we had originally. And there's a SIDX atom now, so now we can actually begin to do something with it. So effectively we've inserted a SIDX atom with references to where all the fragments then exist down the file. So is that it? Is that all we actually need? So I'm going to go with yes, and hope. Ooh, wow, that was terrifying. So what we're going to do is we're going to take all these files and we're going to put them into /library/web server /document/what's in the box. Okay, so now if I go to my browser and we go to WITB, and have a look at our manifest. Hey, great, we've got this MPEG-manifest. So let's talk quickly through a couple of things in this MPEG-manifest. I'll make it a little bit bigger, because it is absolutely tiny. So take a look here, right here. These ranges here, these are really important. So what this is telling us is inside that FMP4 file we're referencing in this manifest, there's two byte ranges you should be really interested in. The index range is our SIDX, so if you go to those bytes in that file, you will find a SIDX box. And the initialization range, so if you go to those bytes in the file, you will find an F-type and a move box. So this is how you can then pick particular bits and declare them with your MPEG-manifest. And this has all nicely been done by Bento for us, so it's generated all this. So if I put this manifest, this is a relative manifest obviously, so I actually have the files in the right location and everything. If I put this manifest into the -if player, do we think it'll play? Yeah? Yeah? Raise your hand for yes? Okay, some people think it'll play. It actually won't on our first try, but it's really interesting as to why it won't work on our first try. Course. Oh, someone actually knew. God damn it, every time. Someone preempted me. If we load on manifest, hey, guess what? No access control origin headers. So yeah, funnily enough, I can't cause to it. So guess what I'm going to press over here somewhere? I have, it's disabled. Oh my giddy. Yes, re-enable the damn button. Hey, guess what? There's a button here I can turn on that turns on cause headers everywhere. It's really useful. Don't ask. Don't even begin. So guess what? Now, if I hit play and it gives me a media not supported error, funnily enough, if I refresh and do this again, it's now going to work. So that button is a bit flaky. But here we go. Here's our MPEG dash. Media serving from an audio and a video, absolutely fine. We're going to allow Daesh, yes, why not? So yeah, so that's pretty cool. We've actually managed to create something, if I pause this, that works in MPEG on-demand profile. So if you uploaded this file into S3, stick CloudFront in front of it, you've just built yourself a VOD system pretty easily that conforms to MPEG on-demand profile. So that'll play 3 or 4 places on the internet, you know. This is when I'm fired. Or at least asked to leave the -if, probably. Okay, so we've talked through all of this. This is mostly just notes. So what did we just do? We contemplated briefly the history of MP4. We discussed a bunch of open and free tools you can use to examine and manipulate these files. We broke some MP4s, yet they still all played, so I guess we didn't really break them that badly. Then we fragmented some MP4s, got ourselves some FMP4, and made them playable by MPEG on demand. And we learnt a lot of 4-letter words. These are a good type of 4-letter words. I like these. So would you like to know more? Read some specs. These are really light reading, by the way. All of them are great. Bedtime reading, for sure. So you've got MPEG4 Part 1. The QuickTime file format's actually a really good place to start if you want to learn some fundamentals, and you don't have to pay or register to get to it. Hey, that's great. All the rest of them, yeah, you're going to have to pay and register for them.
Part 12 is free.
Sorry?
Part 12 is free.
Part 12 is free. There you go. Woohoo! We'll start Part 12, shall we? I think Part 12 is technically patent unencumbered, right? My understanding, or roughly. So yeah, go read the specs, they're really good, but really you're better off just experimenting, get a few files, play with the tooling we've got. If you want to create like encrypted dash out of this with PlayReady or Widevine or Marlin, you can do all of that inside that Bento MP4 dash tool, or you can do it yourself if you've got your keys using MP4 encrypt and just encrypt your media fragments yourself. So people keep asking me all the time, what's your favorite MP4, Adam and Phil? This is a bit of a lie, no one's ever asked me that. It's actually T-Rex, track extends defaults, Trex, I suppose I should call it, because dinosaurs are awesome. So in complete summary, what's in the box? TLDR, sometimes a T-Rex. So it's a half-hour talk to that joke. And that's pretty much it. So questions, comments, thoughts, you can find me on Twitter, GitHub. Don't forget to go and look at Sash. Or you've seen my email already once today, phil@demuxed.com. Cool. Thank you, everyone.